All right, class, so we're going to start with the new section today, which is section 2.7, all about inverse functions. So in 2.7, one of the things that I'm going to bring out to your attention with the inverse functions is there is a very simple way we define these. So let me begin with defining this for you. So when it comes to the definition of an inverse function, it's as simple as, and we did discuss composites yesterday, composite functions, and in essence it's a combination of composite functions and what is the result. So if I have the concept where I'm going to let f and g as functions, so these are two functions such that if I use f of g of x, the result is x, and in the same token, if I do g of f of x, this is x. The equivalent value that remains is x. That is by default how we define f inverse. F inverse of f of x equivalently is another way we express this. So that'll also result in a function value of x. And if I have f of the inverse, so f of f inverse x, the result is also x. Okay? You'll understand this a little bit better as I do more examples, so be patient. Let's start with example 1 so we can start to demystify this for you. In example 1, they're asking you to verify inverse functions. They're starting by giving us f of x as a function is equal to 3x plus 2. And then they give us a second function, g of x, and this function is x minus 2 over 3. They basically want us to show that each function is the inverse of the other. So we begin by, and I would consider this to be the first step. So the first step would be to do f of g of x. And that, in this case, becomes, and let me just color code this for you momentarily. If this is the g of x, okay, so I'm going to, again, we're focusing on f of g of x. If I begin with the notion that f of g of x is equal to 3 times 3x plus 2, so let me just write this the way I'm actually going to work it out. So notice that I leave the gap open here. And notice that this is 3x plus 2. Notice that the x is open because the x is now going to be the x minus 2 over 3. Now mathematically what ends up happening is, in essence, let's see, I used the teal. 3's cancel because that's 3 over 1. That's, in a sense, 1 over 3, so they cancel. This leaves you with x minus 2 plus 2. Obviously, these two cancel with each other, leaving you your final answer, x. So okay, the second thing we do then is, given this information, we're going to do g of f of x, and I'll do the f of x in green to not, all right. So g of f of x, and we're trying to prove that it equals x. Remember, that's our definition. So in this case, I'm going to begin with, I'll start with the parentheses 3x plus 2. And my g, the rest of the g function is the negative 2 over 3. So mathematically, you could immediately see what's going to happen is that the 2's are going to cancel, and you're going to be left initially with 3x over 3, which obviously the 3 cancels, leaving you just x. So again, this is just the definition of what an inverse function equates to. And we just proved it. We just proved it with this example. So I'm going to leave this here on the board for a moment, and I would like for you to do the same thing. So we're going to actually answer this in a try question. Same question stem, nothing's changed. Except the question itself, I'm asking you to find that f of x, or define that f of x is equal to 4x minus 7, and show that its inverse should be g of x, which is x plus 7 over 4. All right, I'm going to stop the video here and give you about 3 minutes or so to try this, and then we'll review it. Okay, so how do we solve this? So let's go ahead and solve this example. So this is the solution. So we're going to begin with f of g of x, which in our case is 4. Notice that I open the parentheses, minus 7. And what goes on the inside is going to be our g of x, which is going to be x plus 7 over 4. Once again, if you look carefully, you'll notice the 4's will cancel. And then this will leave you 4 plus 7 minus 7. I'm sorry, x plus 7 minus 7, which is equal to x, because the 7's obviously cancel. Negative 7 and plus 7 cancel each other out. We repeat the process. Let's do g of f of x. Okay, and so that means that I'm going to have an open piece here, and then plus 7 minus 4. That's my g of x, where the x is now in open parentheses. And what I'm going to plug in is going to be my 4x minus 7. You can see mathematically what's going to happen immediately is the 7's are going to cancel in the numerator, leaving you 4x over 4. And the 4's will cancel, leaving you just x. So yes, we've proven that those two are inverses of one another, and we're good. Now, if they don't give you the two inverses and now you have to find the inverse, is what our example 2 is all about. So here's example 2. And once again, our question is finding the inverse. Of a function. So we begin with if f of x is equal to 7x minus 5. How do we find the g of x, or the f inverse? We're gonna start to call it f inverse of x. That's what we're trying to find. So I'm going to show you a little set of steps. It's my method. I think it works like a charm. So I'm going to start with if y equals 7x minus 5. Notice that I went from f of x to y. That's, in a sense, my step 1. In the next step, I'm going to swap these two guys. So x is equal to 7y minus 5. So I call this a swap. Okay, and here all I simply did was go from f of x, change it to y. Swap x and y in the second step. That's what I did there. And now we're going to solve for y. So I'm going to take my x equal to 7, y plus 5, and I'm going to start with adding the 5 to both sides. And now I'm left with x plus 5 is equal to 7y. And I'm trying to solve for y. So we're going to solve for y, which is what we're doing here. I'm going to divide by 7 on both sides. So f inverse x for my equation is actually equivalent to x plus 5 over 7. So it's change f of x to y, swap f of x and y, and then solve for y. It's that simple. All right, so I'm going to leave this here. I'm going to put the try question right next to here. So find the inverse of f of x is equal to 2x plus 7. I'll give you about a minute or two and try to solve it. I'll work it out with you and we'll go over the solution in 1 minute. So the steps in this one begin with, if I have f of x is equal to 2x plus 7, my next step is to change f of x to y, so y equals 2x plus 7. Here I'm going to swap x and y, so x equals 2y plus 7. And in my next stages, I simply want to solve for y. So I know that this will become x minus 7 over 2 is equal to y. And lastly, I'm going to write the inverse f negative 1. F inverse is equal to x minus 7 over 2. It's that simple. All right, let's look at example 3. Example 3 is more of the same. We're still finding the inverse of a function, except now I'm throwing you into deeper waters. I like deep water. You can swim and not know if you're going to be eaten in the next 10 seconds, but it's fun. Okay, so here's example 3. We're going to find the inverse of f of x is equal to x cubed plus 1. Okay, so before you start to panic and hyperventilate, here we go. Same process. Here's f of x. It's equal to x cubed plus 1. Step 1, y equals x cubed plus 1. Next step, swap them. So x equals y cubed plus 1. Now we solve for y. So we're going to start by subtracting the 1 on both sides. This puts us at a point where if I reverse the y's and the x minus 1, you have y cubed equals x minus 1. And so, as I've taught you, you always use the opposite operation, in this case, the cube root of. So that means that our y value is equal to the cube root of x minus 1. That would be the inverse function of this equation. And so we now express this as f inverse of x is equal to the cube root of x minus 1. It's that simple. Now, what I want you to see at this stage is, let's actually go out to Desmos. So let me pull Desmos up. And let's have some fun with the diagrams. so you understand what it is that you're doing and what it means. And I'm going to show you a very simple, well, actually, let's use this very example. So if I have y equals x raised to the third, this is x raised to the third plus 1, that is our actual diagram. We have basically a cubic function shifted up 1 unit, as you can see. So what does the inverse of this function look like when we actually plot it? So in this case, as we stated earlier, we have y equals the cube root. Now this is interesting. Let me see if I remember how to do this. I think you go to functions. And you should be able to go to miscellaneous. I think miscellaneous, yes, right here, cube. So let's you put in a little 3 in there. And then now you simply fill in the x minus 1. This is the inverse function of this graph. I don't know if you recalled when I actually pulled this number up, that particular number, this particular number. Just focus on those 4 numbers. What do you notice about their x and y values? So if you look carefully, initially you had 0, 1 on the red diagram. And notice that now the inverse function actually has 1, 0 for that same coordinate. On the red diagram, you have negative 1, 0 on the x-axis. It's inverse or reverse the two x and y coordinates. Notice that that's 0, negative 1. So I wanted to bring that to your attention because once you graph, when we start to talk about exponential expressions, for example, so let's talk about exponential functions. So let's say I have, just as an example of the graph and how it relates just coordinate point wise. So if I have y equals 2 raised to the x, this is the exponential function. You're going to see this in chapter section 4.1. If I do the logarithmic equivalent of this, then this will become y equals log base 2x. So this would be the logarithmic. Very difficult to graph or to come up with points, but if I do the exponential in this case, let's go with this. So I'll start with, let's say, negative 2, negative 1, 0, 1, and 2. Let's do some simple math. We know that 2 raised to the second power, well, that's 4, so this has to be 4. 2 raised to the first power, well, that's simply 2, and that's 2. 2 raised to the 0 is always 1, so this is 1. 2 to the negative 1 is equal to 1/2, so this answer here is 1/2. And 2 raised to the negative 2 power, well, that's 1/4, and that's 1/4 here. If I were to graph its inverse, I'm simply going to call this, let's do this in red. This will simply be, here's your x, here's your y. Okay, and let's just color code these for the sake of helping you follow along. All you're going to do is switch them. Negative 2, negative 1, 0, 1, and 2, and your answers are now the same on the y as they were initially. I think I lost my placing here. I like writing it neatly so you can follow along. So this will be the 2 equivalent, 4, 2, 1. This will be the 1/2, and this will be the 1/4. Now, let me show you what it looks like, because it's important that you see that why we do this. It's kind of cool. When we get to sections 4.1 and 4.2, this is literally section 4.1 in your book, all about exponential functions. We'll get there. And this is all 4.2. And at some point I connect this for you again. So you'll hear this again. So let's change our equation. this is now going to be an exponential function with a base 2 raised to the x power. That's what that looks like. And over here, we're going to do the logarithmic equivalent. So let me go to functions. What log? This was what I want. I want log base 2 of x. Is simple. See how they are actually inverses of one another. And that point just proves it. There are other points, obviously, we're going to pull up. If you can see, this is a 0.12 right here. Let me click on it as best I can. See that? That's 1, 2. And this point over here is actually 2, 1. Try and click on it. There you go. 2, 1. All right, so you do have that connection at least to help you with that. Okay, I hope this is helping you grasp the concept or at least refresh old information. Let's now look at example 4. Now example 4, we're still finding the inverse of a function. So find the inverse of a function. All right, and wonderful. And then now what I want you to do is they give us the function where f of x is equal to x plus 2 over x minus 3. All right. Looks complicated, huh? It's actually very easy. We continue with changing f of x to y, and that is now equal to x plus 2 over x minus 3. So that's step 1. Next step, we're going to swap x and y. So this is the big swap. So swap x and y. So this gives us x equals y plus 2 over y minus 3. All right, now we solve. So I'm going to multiply both sides of this equation by y minus 3 on both sides. Obviously, you can see that this will cancel on this side. And it's going to start by leaving you x times y minus 3 is equal to y plus 2. Okay, now we do a little math. We go ahead and we distribute our x. We end up with xy minus 3x is equal to y plus 2. Okay, and this is the stage where most people start to freak out a little bit. And I don't need you to freak out. I need you to move anything with a y to the same side. So I'm going to subtract the y over here. And I'm going to add this 3x and move it over here. So the y cancels, the 3x canceled, and you're left with xy minus y is equal to 3x plus 2. If I factor out this y, I'm left with x minus 1. Notice that the y's are present in both terms of this side of the equation. That's why I bring it out as a common term. And this is equal to 3x plus 2. That nothing changes, just drop it. My last step is always to solve for y, so I'm going to divide by x minus 1 on both sides. All right, and so this will cancel, and therefore f inverse of x is equal to 3x plus 2 minus 1. All right, so this one was a little bit involved. I'll just show it to you here again. So you can just take down any missing notes and make sure you ask questions. I'll give you a minute to just check it out. And I want to do a try question with you, and let's talk. All right, so let's go ahead, and I want to give you this question for a try question. It's the same question stem, so I'm not changing the question stem. Let me see if I can shrink this just a little bit more. Okay, so we're going to find the inverse of the function. Nothing has changed here. And this function is going to be f of x is equal to x plus 1 over x minus 5, where x can never equal 5. Obviously, we don't want the denominator to become 0, and therefore the overall equation undefined. Okay, I'll give you 2 to 3 minutes. Let's go ahead and explore this one. I'll stop the video here. Okay, and our solution for this one, again, we begin with changing f of x to y. So y equals x plus 1 over x minus 5. Now we swap so that x equals y plus 1 over y minus 5. Now we want to multiply both sides by y minus 5. This is y. It cancels on this side. Notice that the y minus 5 will cancel here on the right hand side. We are left with x times y minus 5, and this is equal to y plus 1. Okay, again, remember at this stage I'm distributing the x to get xy minus 5x. I like how I write a y as I'm doing x. 5x is equal to y plus 1. All right, I'm going to subtract that y and bring it to the left-hand side of the equation. I'm going to add the 5x and move it to the right-hand side of the equation. And so in doing so, I'm now left with xy minus y is equal to 5x plus 1. If I factor out a y, I'm left with x minus 1 is equal to 5x plus 1. And my last step to obtain the inverse is simply to divide by x minus 1, because our last stage we're simply solving for y. Okay, so this all cancels. And you are now left with f inverse x is equal to 5x plus 1 over x minus 1. And that is your inverse function for this example. Now, if at any time you guys want to take a pause and just do a few sample questions, we could just practice a little bit. And I'll throw some questions your way and we'll have some fun with that. Okay. In the next example, we are going to talk about what is a one-to-one function. So this is called the horizontal line test. Nothing new, you guys have seen this before. I'm actually going to switch pages. Give me 1 second. Let's see here. Okay, so we're talking about the horizontal line test. And one-to-one functions. I have briefly talked to you guys about this when we talked about the vertical line test. So in essence, the definition of the horizontal line test for inverse functions. So this is a definition. So this is the horizontal line test for inverse functions. says a function has an inverse that is f of -1 if there is no horizontal line that intersects the graph of f at more than one point. So, as an example, if I have a graph, let's say hypothetically I have an inverse parabola. Let's take the parabola, inverse parabola, and we engage in a horizontal line test. Do you notice that I'm hitting the graph here and here? And in this case, we would say that this has no inverse function available, no inverse. I can give you another example just to make sure that you're catching what they're getting at. Basically, if I have a diagram that looks like, let's say it's doing this behavior. Again, if I drew a horizontal line crossing more than one point, if you notice here, I'm hitting the point here, I'm hitting here, I'm hitting here. I'm hitting this actually. This actually has no inverse. Okay, now if I had a diagram, let me give you an example of its counter. If I had a diagram, and this diagram actually went as such, will it pass the horizontal line test? Am I hitting more than one point at any point? No. So this would have an inverse. All right, so that's the example. All right, this would be example 5, by the way. I don't think I mentioned that. This is all about example 5. Okay, let's look at example 6, where we're graphing. And I've already given you a little preview as to what to expect for the graphs and what we're looking at. And so the first thing we want to take a peek at here, if I'm graphing the inverse of a function. Okay, so I'm going to give you, this is example 6. So we are graphing an inverse function. I'm going to give you 3 coordinate points, and I want you to graph them on your paper. And these are straight lines between these. So they're giving you -3, -2, -1, 0, and 4, 2. So just take a moment. -3, -2. -1, 0. And 4, 2. And in essence, they're basically drawing a direct line to each of these respectively. If I want to draw its inverse, I'll do the inverse in red. Notice that I'm simply going to start diagramming -2, -3, 0, -1, 2, 4. Okay, so if I'm doing 2, 4, at x is 2, y is 4, over 2 up is 2, 4, 0, -1, I'm down here, and -2 on the x, -3 on the y, which is right here. So if I draw these lines, That's the inverse of this diagram. That's all you have to do for an inverse. So for your try question on this example, if you need me to pause the video, I will. They're asking you to draw the inverse or graph the inverse. They're giving you the points -2, -2. They're giving you they're saying to draw -2 to -1, 0. -2, -2 to -1, 0. So this is what they call segment 1. And in segment 2, they want you to draw -1, 0 to 1, 2. And then find its inverse. Okay. So if you're going to have any confusion with this one, all they're asking you to do is start with the points that they give you. So we start with -2, -2. And we're going to go to -1, where x is -1, 0. So we're here. And from -1, 0, they want us to graph at 1, 2. So 1, 2 would be right here. That's what they're asking us to graph. So now we need to then draw its inverse from here. So I'll give you a minute to think about that, and then we'll talk together. So in the solutions for this, you would still have -2, -2, because there's nothing that can be swapped there. I would definitely do 0, -1, and then this other point would be 2, 1. Okay, so if this is these are our coordinates. Here's the -2, -2. 0, -1 would be down here, and 2, 1. So that would be somewhere about here. So this diagram would have this shape. Looks kind of funny. I'm going to make sure that we're doing this correctly. So this is -2, -2. That's not going to change. 0, -1. Right? Because that would be 0, -1. And then the 1, 2 would be now x is 2, y is 1. That's exactly what it would look like. Strange looking little fella. But hey, basically you're swapping x and y. This becomes x prime, y prime. The original coordinates, again, I'll just write them here. So -2, -2. And the other coordinates are, in this case, -1, 0. And this coordinate is 1, 2. And that's the original x, y that they give you. Just follow the color code. I gave you the colors up here. It does look strange, doesn't it? I don't know about you, but I think it looks strange. Okay, our last example, example 7. This is called a domain restricted. Function. This will probably be the area where you have to analyze, and it'll cause you a little bit of heartache and hardship, but you'll be okay. So you're finding the inverse of a domain restricted function. Okay, so let me give you the example that they're getting at. For example, if we have a parabola, and we already discussed that a parabola fails the horizontal line test. So we already know that if I need to find the inverse, and let's say they give me the function where f of x is equal to x squared minus 1, and we're looking for the inverse at x is greater than or equal to 0. So if I'm looking at my parabola just from a general perspective, we know that the parent graph of the parabola sits at 0, 0. We're shifting it down 1 unit. So basically our parabola sits somewhere down here. If I'm looking for this inverse, so if I go ahead and I say, okay, well, y is equal to x squared minus 1. I swap x and y, so x is equal to y squared minus 1. I end up with, in this case, y squared is equal to x plus 1. And I solve for y, so my y inverse, or f inverse, is the square root of x plus 1. Now I want you to stop and I want you to think about what that means to you. If I'm doing a square root function, remember this is y inverse, so this is basically f inverse, which is now the square root of x plus 1. Remember the rule that I established with you, and I said to you, all the stuff in the middle, so that x plus 1 has to be greater than or equal to 0, which means that x has to be greater than or equal to negative 1. So if I draw its inverse, here's, let's assume this is negative 1. This inverse is going to shoot out this way. So it's domain restricted because x has to be a positive number. So regardless, I'm over here on this side of the parabola, as far as the parabola. So in essence, I am going to eliminate anything that's over here in the pink, minus that point that I have the blue on, right? So my new diagram, if I were to draw it out, let me actually erase this piece, would look like that. This would be the inverse function diagram of a parabola. So you actually do literally ignore the negative side of the x values, because this was a distinct requirement of the question. All right, that's what I have for you for now, and we do have some sample questions we can go review together.